Good day everyone. Our topic for today is analysis of variance one-way classification. But before that, don't forget to like and subscribe to this channel and hit the bell button for more updates. Also, you will find different subjects in this YouTube channel. Just select the playlist section. And now let's proceed to our main topic for today, which is all about analysis of variance one-way classification. What is analysis of variance, or ANOVA? A general method of drawing conclusions regarding differences of population means when two or more comparison groups are involved. The t-test is a special case of ANOVA when considering only two groups, but if the group are more than three or three more than, then we will use analysis of variance. To test the equality of several means, researchers utilize a procedure known as the analysis of variance. One-factor analysis of variance is a procedure that uses a set of calculations on several variances to test the hypothesis that several populations have the same mean. The following are the steps in solving the analysis of variance. Step 1. Determine the null and the alternative hypothesis and the computation. Step 2. Find the SST, mean to say sum of the squares total, where SST is equal to summation of x squared minus quantity summation of x squared over n. Next, where summation of x is equal to a plus b plus c, and summation of x squared is equal to summation of a squared plus summation of b squared plus summation of c squared. Step 3. Find the SSB, sum of the squares between, where SSB is equal to a squared over n plus b squared over n plus c squared over n and so on, minus to the quantity summation of x squared over n. For step 4, find SSW, sum of the squares within, where SSW is equal to SST minus SSB. Step 5. Find the variance estimates, the mean squares. The formula for the mean squares are MSB is equal to SSB over K minus 1. And MSW is equal to SSW over N minus K. Where K is the number of groups, N is the total sample size. Degree of freedom is DFB is equal to K minus 1, and DFW is equal to N minus K. DFB is the numerator and DFW is the denominator. Step 6. Find the F ratio and complete the ANOVA test, where F is equal to MSB over MSW. Example number 1. Find if there is a significant difference between the three tested diets using 5 students. The alpha is equal to 5%. I think that diet is not applicable for 5 students. Maybe we can use rats, cats, or dogs, but not human. But anyway, it is in the problem, so let's see. For the diet A, we have 9.3. I don't know what 9.3 is all about. 8.0, 6.5, 6.7, 6.0, 6.3. Maybe this will be their kilogram. The diet B is 7.3, 6.7, 6.5, 5.5, and 5.7. And diet C is 5.5, 5.7, 6.1, and 6.0, and 5.0. So I think the appropriate word here It's rats, not students. Okay, we will change it first before we proceed to our um, lesson. So it's rats. Okay, so let's proceed to step 1. The step 1 is HO, or the null hypothesis. There is no significant difference between the 3 tested diets using 5 rats. HA, there is a significant difference between the 3 tested diets using 5 rats. Okay, now, for the computation, we have the following. For the diet 1, at diet A, B, and C, these are given. This, oh, I'm sorry. What happened? Okay, so these are given, these diets. Okay, it is given in our previous presentation or table. And now, for the diet A, we will get the summation of A, or the total of A. So we will just add all of this and we will get 36.3. For this one, we will add that summation of B. We will get 31.7. This one, we will get 28.3 for the summation of C. For the A squared, we will multiply this A by itself. 9.3 times 9.3 is 86.49, 64, and so on. And get the summation of A squared, and you will get 271.07. B squared is summation of B squared, 203.17, and for the C squared, we have 160.95. I hope you already got how we compute these numbers. Okay. For the number of groups, as you can see, we have diet A, B, and C. That's why we have 3 groups. Number of observation, we have 5 number of observation, right? And then, for the total number of observation, just multiply the number of groups and the number of observation, and we will get 15 as our capital N. By the way, 3 is equal to K. 5 is equal to small n, and 15 is equal to capital N. For the summation of x equals a plus b plus c, we have 36.6. A, B, C are summation of A, summation of B, summation of C. So we have 31.7 and 28.3. What is now the total for the summation of x? That is 96.3. Now we have summation of x squared. So we will just add summation of a squared plus summation of b squared plus summation of c squared from our previous table. And we will get these values. And just get the total, we have 635.19. For step 2, SST is equal to summation of x squared minus quantity summation of x squared over n. So we will just put the numbers here. What is quantity? 96.3 squared over 15. You will get 618.25. So subtract it from 635.19 and you will get 16.9 for the SST. For the SSB, just have this formula. So we have a squared over n, b squared over n, c squared over n minus summation of x squared over n. So these are the a values of a, b, and c, and summation of x. We got this in step number 2. So 36.3 squared over 5 is 263.54. 31.7 squared over 5, 200.98. 28.3 squared over 5 is 160.18, and 96.3 squared over 15 is 618.25. 15 is the total number of all the observation, and is the total number is the number of observation. And then add all the numbers or the all the three numbers, we will get 624.7 and subtract it to summation of x squared over n, and we will get 6.45. For the next step, we have SSW equals SST minus SSB. So we have 16.94 minus 6.45, and you will get 10.49 as our SSW. Next, step 5. MSB is equal to SSB over K minus 1. Our MSB is 6.45. And K minus 1, K is equal to 3. We have 3 total number of groups. That's why 3 minus 1 is 2. And you will get 3.225. For the MSW, we have SSW over N minus K. Our SSW is 10.19. We computed already this one. N is the total number of observation, which is 15, and the number of group, which is equal to K, is 3. So 15 minus 3. And we will get 12 divided to 0.8742. Now, for the F, we have MSB over MSW. And for the MSB, we computed 3.225. For the MSW, we computed 0.8742. And divided to, we will be having 3.69. Our computed value of F is equal to 3.69. F is what we call the F ratio for the ANOVA. Now, the critical value is at 5% level of significance with K minus 1 is equal to 2 and 12 for the degree of freedom, which is N minus K for the degree of freedom. I already gave you the formula for this, the DFB, right? And DFW. DFB is the denominator, and numerator, and DFW is the denominator. So the numerator is 2 and the denominator is 12. And the critical value of 5% with 2 and 12 degree of freedom is 3.89. To check this, let's have this F table. So you may download this F table in Google. So let's make it bigger. Okay, so our degree of freedom for the numerator is 2. So this is 2. Okay, now we will look for the denominator. The denominator is 12, so we will look here in this side. Okay, the denominator. There is a word denominator. So we have 2. So let's look for 12. Okay, that's it. I already saw 12. And then where's 2? We have 2. Okay, so the second, these are the 2 and 12. Now, our level of significance is 5%. Therefore, the intersection is 3.89. This is 5% of 12 and 2. And we have 3.89. So let's see. That's correct, 3.89. That is our critical value. Our computed value, in summary, the sums of the square is 16.94 and 6.45. The DF is 2 and 12. The mean squared, or the MSB and MSW is 3.225 and 0.8742. For the computed value of F, we have 3.69. For the tabular value of F, we have 3.89. Yun yung nasa table. Now, decision accept HO because our computed value is still under 3.89. Nasa loob pa rin siya ng 3.89, right? So therefore, the interpretation is not significant. Hence, to sum up, the conclusion is there is no significant difference between the 3 tested diets using 5 rats. I'm sorry, this is rats. Okay? So that's all about for the analysis of variance one-way classification. With that, thank you very much for listening and good day.